Okay. Everybody to sketch a graph using an intercept. I believe there was a assignment on that, so you might want to review it. Okay? I'm not gonna double check the assignments, but it should have been. If there wasn't, that's all right, we'll fix it. Okay, now. Point two, here's point three, and here's point four, and here's point five, and here's point six. One. Six, those aren't coordinates, I'm just numbering the points, right? Use your fingers. Should show me one of the points that's on the x-axis, 1, 2, 3, 4, 5, or 6. Okay, number 3 is on the x-axis. Okay, is there another point in the x-axis? Yeah, number 4. Okay, so these 2 points are on the x-axis. So what is the, okay, let's say that this, now a lot of people have chosen 1, 0. Matter of fact, that's what everybody that chose a point chose. Okay, that's perfectly good. I asked everybody to give me a point that was on the x-axis, right? So that's what they did. But let's say 1, 0 is right here. Let's just say that's the point 1, 0. Okay. Then would you agree that the y coordinate of this point is also 0? And the y coordinate of this point is also 0? Okay. So my point is that the next intercept is on the x-axis. Okay. So at an x-intercept, y equals 0. Okay. Now, can you give me the number of a point 1 through 6 that has a y coordinate, that has an x coordinate of 0? Yeah. 5 has an x coordinate of 0. There another one? Yeah. Everybody's gonna see it, it's 6. Okay, so points 5 and 6 have x coordinate 0. So if the points number 4 and 6 are x coordinate is 0, that's our 4 and 3. And or if we look at the x-intercept, the y coordinate is 0 at points 4 and 3. I was about to write this. This needs to go before this. I'm sorry. Okay. Y coordinate 0. And that's where the x coordinate is 0. Somebody asked how I was doing today. You can see. Okay. Now we got that straight. I'm sure you had it straight. I just had to write it down straight. Okay. So the y-intercept x equals 0. So how are you going to find the x and y intercepts of this equation? It's not showing on the board, but there's the equation. Okay, that's the first equation on the quiz. Okay, well, kind of left it at this. One comment that I really need to make is from the work I'm seeing on paper here, it doesn't appear that people are drawing these graphs on their paper. It appears they're content to draw the line on the screen, but you don't know how to translate that to paper. Now, it's very easy to do that. You won't have any trouble doing it if you think to do that. Everything you do in this course, you need to do on paper. Okay? Don't be content just to do it on the screen. You don't learn it that way. You learn it by putting it on paper. Okay, with pictures, if pictures are relevant, which they certainly are with graphs, okay? This is how you put it together so that in the next course you take, you're not stumbling over the concepts that you would have reinforced better if you'd have drawn it out, okay? I'm not sure how much I've stressed that at this point, up to this point, because everybody's been doing pretty well with the algebra, and the work I've been seeing is looking pretty good. As soon as we get the graphs, and this is the first day I've really looked at your graphs. I just need to draw that to your attention, okay? Make sure you're drawing these graphs. You should probably go back to the assignments that everybody did well on, okay? And sketch the graphs. And I don't mean just copy them from the output you see on the screen. I mean, start at the beginning, don't look at the screen, take the equation, work out the graph. You've done everything else, so that's going to be a pretty easy exercise, okay? So, anyhow, okay, look, we're trying to get these intercepts and so forth. So we've got the equation y equals, sorry, negative 4x six. It's written so bad I got started. Negative 4x times 6y equals 24. X-intercept, y equals 0. So negative 4x plus 6 times 0 equals 24. Two things you got to do here. One thing is identify that we're looking for an intercept. We choose the x-intercept. You do the y-intercept first. It doesn't matter which one you do first. This shows let's do the x-intercept, then y has to be 0 because of what we just drew up here. Okay? And you really need to understand that. You really need to have that locked in. Otherwise, you're going to forget it. And one of the things I see in pre-calculus classes is people keep forgetting that. People get 3/4 of the way through the course and they still don't know that the x-intercept occurs when y equals 0. And they're stumbling over it. And they don't do as well because they keep stumbling over it, regardless of the fact that I nagged them about it about 50 times by that point in the course. They just won't lock in on it. So there's something that's difficult to lock in about that idea. It's not that people are deficient, they're good, hardworking people. And so are you, okay? What I'm strongly recommending is you make sure you have this idea. And anytime you're looking for intercepts, this is how you think. Okay, x-intercept, y has to be 0 because every point on the x-axis has a y-intercept of 0, as you know. If you don't bring that thought out of your memory, you're not going to do as well, okay? If you just memorize y equals 0 for the x-intercept without seeing why it is, you won't remember it. You get it confused, okay? So there we have it. So once we write this down, we can solve this for x, right? That gives us negative 4x plus 0 equals 24, which means that just negative 4x equals 24. Now, don't make the mistake of thinking you can add 4 to both sides to make something go away. you can't add 4 to both sides of this equation and have any good effect because this is 4x. Okay, it's negative 4x. If you want to get rid of a negative 4x, you add a 4x, not a 4, because x could be any number. Okay? And if you add 4, well, 4x probably doesn't equal 4, because x probably doesn't equal 1. All right? So, and I see that mistake fairly often. Not seeing a whole lot of it here, but I am seeing some of it. Okay. What do you do here? Negative 4 is multiplied by x, so you can divide by negative 4. Okay. And then negative 4 divided by negative 4 gives you 1, which just gives you 1x. 24 divided by 4 is 6, but you're dividing a positive by a negative, so you get a negative. Now write the 1 because negative 4 over 4 equals 1. But then that just comes down to x equals negative 6. Right? Okay. At this point, well, I'm gonna quite do this in the order I want you to do it in to make my point. Okay, so we want the y-intercept. Y-intercept, x equals 0. So we have negative 4 times 0 plus 6y equals 24. Okay. And that gives us 0 plus 6y equals 24, which gives us 6y equals 24. And then we can simply divide 6y by 6 to give us 1y. 6 divided by 6 is 1, equals 24 divided by 6 is 4. So that y equals 4. Now, at this point, people make a mistake, and I see this very, very frequently. Okay, 30%, 60% of people will then say, okay, we got the point negative 6, 4. Well, the point negative 6, 4 isn't on this graph. Because if I substitute x equals negative 6, I get 24, right? If I substitute y equals 4, I get 24 again. So I get 24 and 24, which is 48, not 24. So big deal. Negative 6, 4 isn't on the graph. Plug it in, and you find that it's not on the graph. And it certainly isn't an intercept. You're trying to find the intercepts. Negative 6, 4 is not an intercept. Neither of the coordinates is 0. The y coordinate isn't 0, so it's not the x-intercept. The x coordinate isn't 0, so it's not the y-intercept. This has nothing at all to do with the graph. Okay? So see if you can lock that idea in. I stress that because, again, I keep seeing it. Okay? The pre-calculus class, in this class, in the support course with pre-calculus. Okay. How did we get x equals negative 6? We assumed that y was 0. So x is negative 6 when y is 0. So moving past my warning. So the x-intercept is negative 6, 0. Okay? And over here, makes sense? Okay. So now we know what the x and the y intercepts are, so we have to put those points on a graph. And that's where we are right now. So go ahead, sketch yourself a set of coordinate axes and mark a point for negative 6, 0 and a point for 0, 4. So if you haven't done that, go ahead and do that. Mark those 2 points on a set of coordinate axes. And now to out this equation, sketch a set of coordinate axes. All I'm going to do is I'm going to say negative 6, 0 is a point on the graph, right? I'm just going to say negative 6, 0 is about here. I haven't put a scale on the graph yet. If you draw your scale before you draw your graph, there's a good chance that your graph is not going to fit well on the scale. Your points might not even fit on your scale. Okay, so I draw the points before I draw the scale. Then 0, 4. Well, if that's 6 units, then 4 units is maybe about here. It's not necessary for your y scale to be the same as your x scale. In other words, 1, 2, 3, 4, 5, 6, 7, 8 on your x scale. Your y scale might have 1, 2, 3, 4, 5, 6, 7, 8 with the points closer together or further apart. Okay, but right now it's probably best to use equal scales, but it's not always possible. If you're modeling the value of the stock versus the number of weeks, the value of the stock might be in the hundreds and the number of weeks might be 5 or 6. So you need hundreds up here and you need 5 or 6 on this scale. And you wouldn't want 5 or 6 to be like this and the hundreds to be on the same scale because it'd be through the ceiling. So you don't always use the same scale. You don't ever even assume you have the same scale. Okay? But for a lot of the problems you have right now, the same scale seems to work because open math usually uses an equal scale. Okay? So it's reasonable if that's 6, that should be 4. It's not going to be exactly so, but it's reasonably close. So now I can sketch a line through those 2 points, straight line. Make sense? Now we want the equation of the line. I didn't even ask you to graph it. But once you have the intersection, that's what you do. And often the easiest way to draw your graph is to have the intersects. It's the first thing you're going to try. Doesn't work well when one of the intercepts is really close to the origin and the other is. Okay, if your intercepts are too close to the origin, it makes it difficult to get a good representative graph. You want to use the slope, so forth. And we're going to do that. Okay, so we find the slope of the graph. What's the slope? Well, we've got 2 points. We can find the slope. Now you have a formula that people can easily mess up. Okay. I don't like that formula. I don't like that formula without the picture. If you've got the picture to make sense of the formula, then you're on firmer ground. Okay. Now, if you got the formula, if you've memorized it right and always use it right, I find that acceptable. I don't think it's the best way, but it's okay. right? It's not as reliable as the picture, and the picture is this. I go from this point until I'm right below this point. So I start at one point and go right as far as I need to, so that I can then go up or down to the next point. Now, see, this point could have been down here, we'd have had to go down. We have a path from here to here. We don't draw this arrow going this way, okay? And this arrow going this way, because that doesn't give us a path. If the arrow's going this way, we can't get from here to here. Does that make sense? This arrow tells us which way to go to start from this point and get to this point. And this arrow, I'm going to call the run. And this arrow, I'm going to call the rise. Now, did you see those words anywhere in the open math? Okay. You see rise and run. I'm afraid open math then ignores rise and run and just uses the formula to find slopes. I want you to draw the pictures. The reason I want you to draw the pictures, I want you to be successful in a pre-calculus course or whatever other course you might be taking this as a prerequisite for or as a preparation for. Okay? And if you're going to be successful, you just get this idea of rise and run in this picture. That's a really easy picture to draw. Okay? So what's the run? You can count in this case, but of course you're going from -6, 0 to the origin. That is going to be 6 units, right? The run is 6 and the rise is 4. Okay? Well, I complete a triangle because that triangle is, I think, a very important picture. The slope of that triangle is your rise divided by your run. So is the slope of your roof. Okay? If it's 4 and 12, that means, and that's a fairly common measurement for a house that's like 24 by 40. Okay? And they're pretty common. Okay? You got 12 feet to the center beam. Okay? The center joist. Okay? Depends whether it's a beam or joist. And then you go up 4. And you got a slope about like that. You don't want much less slope than that because you get ice dams and stuff like that. It doesn't drain as well. My wife made me build a 12 and 12. You can't walk on it. Okay. You can't even walk on a 10 and 12. You can walk on a 9 and 12, but it feels really insecure. Okay. I don't walk on roofs anymore. Okay. I'm well past the age where that's a good idea. If I had to, I think I could, but let's leave that to somebody else these days. Okay, anyhow. So you can think of a roof if you like, the rise and the run. You know, go around looking at roofs. So that looks like about a 7 and 12. Okay. That's about a 3 and 12. That's going to be trouble. Okay, well, take it. Okay, so your slope is a rise over the run, which is 6 over 4, which is, oh man, I will tell you that I'm a little bit dizzy today. My sinuses. And I'd like to blame everything on my sinuses, but nah. Now, the rise is 4 and the run is 6, and that reduces to 2/3. Of course, that's 8 and 12, okay? It's hard to walk on an 8 and 12. You don't have enough friction to feel secure. It is secure if your sense of balance is okay. You're not likely to slip off unless you walk on it on a frosty morning. Okay, well, anyhow, there it is. So that's how you find the slope. And I won't insist on it, although I might ask you on a test to sketch that problem, and you should be able to because you don't, okay? So I really recommend every time you calculate a slope, until you've calculated at least about 50 of them, that you draw that triangle to reinforce what the slope means. The formula doesn't tell you what the slope means unless you understand the picture. And the picture tells you what the formula should be. So the formula and the picture reinforce each other. So you want that to happen. Okay, you want to do these problems in such a way that that happens. All right. Anyhow, there's our slope. Now, we want to find the equation of the line with the same slope having y-intercept 0, -4. Well, I think that the homework that everybody seems to have done pretty well on involved the slope-intercept form. So the same slope, y-intercept 0, -4. Y equals mx plus b. What's m stand for? Stands for the bleeping slope, right? So once you found the slope, you know what to put in front of x. What's b? It's the y-intercept, which is 4. Okay, you don't put 0, 4 here. There's a little ambiguity in the way the y-intercept is given. They'll say the y-intercept is 0, 4, but sometimes they'll just say the y-intercept is 4. It's ambiguous. So I will say the y-intercept is at 0, 4. The y-intercept is 4. Okay? A little terminology you might want to think about it. Probably not going to stumble over because you're going to know from the context what you're doing, but I mean, they use B for the y-intercept, right? They say B is the y-intercept. So B is 0, 4 if you think the y-intercept is 0, 4. If you think the y-intercept is at 0, 4, and that doesn't mean it is 0, 4, that means that's where it is. But it is B, which is 4. Okay, if that makes sense to you, okay. If it doesn't, it's worth pondering. It's just a little bit of precise English. Okay, but if you find it confusing, you can ignore it. Just make sure you know that that's B. That's B. And the y-intercept is, oh yeah, yeah. So the y-intercept is 4. That's for this line. What's the equation of this line? I didn't ask you to find the equation of this line. But this line is y equals mx plus b equals 3/2 x plus 4. Now, here the y-intercept, we want the same slope, but want the y-intercept to be 0, -4. It's going to give us a different equation, isn't it? Okay, so that's going to give us y equals mx plus b. M is still 3/2, but now b equals -4. The equation is y equals 3/2 x minus 4. Okay, and got corrected again. Once I got that 3/2 in my head, I think somebody wrote that down, so I'm gonna blame it whoever did that. Nah, I'll take credit for it. Okay, it should have been 2/3. And this should be 2/3. At M, it's still 2/3, not 3/2. Okay? Sorry for any confusion, but this is how you do it. Okay? You get the slope from 2 points. You've got 2 points, you got the slope. Okay? And if you know where the thing crosses the y-axis, you know where the y-intercept is at. It's at a point, and the y-intercept is the y-coordinate of that point, which is 4 in this case. Now, if we change the y-intercept to 0, -4, you get 2/3 x minus 4, right? Now, can you graph this? How do you graph this? Well, you have seen how to graph a line given its equation. Okay, I've seen people do it. The y-intercept is at -4. Now I'm gonna circle this with orange. So I'll write everything up here for this equation in orange. And circle this around. Okay, so the y-intercept of this equation is -4. This point is 0, -4. And now the slope is 2/3. Okay, that means you get another point on the line. You can move over 3 units. That's the run of 3. So I move over 3 units and up 2. Okay, and then I could sketch a line through these points. That line is going to be parallel to this line because it has the same slope. You build 2 roofs with a 8 and 12 slope, fairly steep, about as steep as you want to walk on. And you look at those 2 roofs, you will get, maybe this one's on a hill a little higher than this one. Those 2 roofs are going to be parallel. Okay, we're going to have a slope of 2/3, which is the same as 8 and 12. If you want to draw it by intercepts, you could of course find the x-intercept. You let y = 0 and solve for x, because that's how you find intercepts. Equation doesn't have to be in this form to use that. Okay. The equation's in this form. Again, you let y = 0 and do the arithmetic. You know, do the simple L. Okay. Make sense? Okay. Also, if it's in this form, it's really easy to find the y-intercept. You let x = 0. And right there it is. Of course, you know that's the y-intercept anyhow, when the equation's in this form. Okay. So this is now the equation. That little triangle over 3 up 2, so the slope is 2/3. Of course, you might be better off going over 6 and up 4. Okay, you can double these. You go twice as far over, twice as far up. You locate the point more accurately if the points are too close together, but still, there's the idea. Okay. No, I didn't locate those points quite right because those things aren't really parallel the way I drew them. And there's no way I can draw 2 perfectly parallel lines. Okay, nobody can. But they could have been a little better. I'd use the intercept on this far over here. Well, it looks about right. So I don't know. maybe my 4, yeah, this 4. This 4 is a little bigger than this 4, so the thing is a little too low. You get the idea. Okay. Now, I'm going to give us a little more time to really get this done. Okay. So I'm going to right now, I'm going to take a second and just modify the assignment schedule a little bit. Okay. Now, I'm going to find the equation of line through 27 points 27 and 83. Okay. First thing to do, and do this, take a piece of paper and sketch a graph and put 0.27 and 0.83 on the graph. Actually, you don't even need to draw the coordinate axes. Just draw 2 points that could represent 27 and 83. I mean, you know, like if one points to the right of the other, make sure it's to the right. And if it's up or down, make sure it goes up or down correctly, right? It just showed me 2 points that could represent 27 and 83. Okay, now what I said was do this, don't even draw a set of coordinate axes. Okay, almost everybody drew a set of coordinate axes and then tried to put the points on it. What all I want you to see is, okay, 27. Okay, well, I can put 27 any place. Now, where is 83? Is it to the right or left? Okay, so let's draw an arrow to the right. How far is it to the right? Show me some fingers. No, well, a minute, let's make sure we see this. Yep. How far do you have to go to the right from 27 to get to 83? That would be from 7 to 8. 7 to y coordinate, 8 is an x coordinate. Okay, people having trouble with this, so let's be sure we understand. And again, this goes back to, I don't want to be critical of open math because I'm the one that selected these problems. Okay, out of a problem bank, and I didn't have time to write my own. But I think open math is overly, at least the open math assignments that I've chosen, and I couldn't find any that weren't, overly dependent on formulas rather than pictures. Okay? So you probably need to go ahead and sketch a set of coordinate axes. Okay? My point is from x equals 2, this is at x equals 2. And this is at x equals 8. Okay? Now, where is x equal 2? X equals 2 at every point on a vertical line through 2, 7. Okay? As the x coordinate is the same everywhere on a vertical line. This line represents x equals 8. Now, this did occur on the assignments. Okay, you had a picture of a vertical line, and what's the equation of this line? And people typically, and I'm talking 80% of the people, will draw one point and tell me that that's the equation of the line. Okay? So I inserted some fairly extensive comments in many of the homework assignments, so you want to read those, okay? But I'm gonna say it here. And I think I inserted those comments just like yesterday, you might not have time to look at them anyway. Or digest them, because it takes some digestion. Okay, so let's see, there's 8 marks, right? Well, vertical line. To the mark where x equals 2. And I'm gonna say this dotted line is the equation x equals 2. What's that mean? It means I give you the equation x equals 2. It consists of every point that has an x coordinate of 2. Now, one, two, three, four, left to right. Which point has an x coordinate of 2? Third point, right? That point has an x coordinate of 2. What's the x coordinate of this point? Show them with your fingers. Probably between 2, just give me one of them. Well, if it's between 3 and 4, just give me a 3 or 4, I don't care which. Okay, anybody else going to vote? What's the x coordinate of this point? Yeah. Okay. To get the x coordinate of a point, you draw a vertical line down to the x-axis and see where you are. It's between 7 and 8. If I really put 8 points, I'm pretty sure I did. Okay. So this line might be x equals 7.4. The way I drew it. Okay. Could you draw the line x equals 8? Yeah, it's going to be a vertical line that goes through the x-axis at x coordinate 8. This is the line x equals 8. We don't need the line x equals 7.4, but it's already there, so we'll just use it. I mean, we'll just keep it. But we don't use it. Now, if we're going from the point 2,7 to 8,3, how far do we have to go? Well, the point 2,7 is somewhere on this line, and the point 8,3 is somewhere in this line, because x equals 2 here, and x equals 8 here. Okay, now, where is it on this line? Well, this is at y equals 7, right? So can we draw y equals 7? Well, if I'm using the relatively equal scale, we're just going to say y equals 7 here. Okay. Now that tells me I got to make 6 marks in between 0 and here equally spaced if I want to mark off my units. Okay, and I can do that. I'm gonna ask, okay, where's y equals 3? If this is y equals 7, where's y equals 3? Okay. So I'm gonna draw points here. 1, 2, 3, 4, 5. Which of those points makes more sense for y equals 3? Well, 3 is going to be a little less than half of 7, right? So between 0 and 7, halfway is 3.5. That would be like right here. So this is a little closer to the x-axis than it is to the y equals 7 line. Okay. So I'm going to say this is probably the closest to y equals 3. Question mark there, because this one looks almost halfway. That looks like more like 3.5. Still, we're just trying to draw a diagram. And what this tells you then is that the point 2,7 is where the x equals 2 line and the y equals 7 line come together. Okay. So this is the point 2, 7. Our x=2 line intersects our y=7 line. And we're out of time, but we'll just do this real quick. And our point 8,3 is here. And the x=8 line intersects the y=3 line. Okay. Now, what I would hope, if we do this, we see that 8 is to the right of 2, because x=8 is to the right of x=2. And y=7 is higher than y=3. So when you draw these points, you should have drawn the second point lower than the first. A couple people did, a couple people didn't. Okay. At least one person drew the second one higher than the first, and I'm not sure that everybody drew the 2 points, but everybody's at least in the stage of lining off a set of x and y axes, which was probably a good idea at this point. Okay. So here is the y=3 line. Here's the y=7 line. Here are the 2 points. We never needed a set of coordinate axes as long as we think about what's to the right and what's to the left and what's up and what's down. There it is. And from here, you could calculate the slope. Okay. The run is 6. The rise is -4. Slope is -4/7. You should always, if you're given 2 points and need to find the slope, sketch those 2 points. Don't even bother with a set of coordinate axes unless you really need to, and work on it until you don't need the coordinate axes, or you could just draw this picture with a line for y=7, a line for y=3, a line for x=2, a line for x=8. Then if you want, you can say, well, the y=0 would be about here. So there's my x-axis, and x=0 would be about here. So there's my y-axis. Okay. Draw the points first. Now, if you got to draw this first, okay, but try to wean yourself from the need to do that. So you can just see, here's 2 points, here's the rise, here's the run. Now I've got the slope. And then you can use that to fairly easily find the equation of the line. You don't have a y-intercept now, so you got to do a little work. And we'll pick up on that next time. Fair enough? Draw pictures, write things out. Get as much of that done as you can before Wednesday and try to lock in all the stuff that you've seen in sections 2 and 3. Everybody, I think, was pretty good with section 1. Okay.